Hello, my name is Mayara. I am a PhD student of André Morandini. Thank you for the opportunity for making me presentation. So I'll talk about the role of cnidarians, a brief review and new science of feeding mechanisms. So, if I ask you what is the capture mechanisms of medusa, you will probably say nematocyst, right? And if I ask you what's the mode of flow promotion in medusa, you will probably say bell pulsation. And this is right. This is exactly that we found in the literature. But we have some indications that there is another mechanism of capture and another mode of flow promotion in medusa. That's its cilia, like we can see in corals. So my guiding question is, do medusa have cilia that promote flow and capture particles? In this context, we analyzed the different mechanisms of suspension feeding and sorted them according to a proposed classification framework. So we analyzed all data available in the literature about suspension feeding, and we sorted the mechanisms that we found based on our classification framework. And after that, we present a scheme with the phases of pelagic jellyfish suspension feeding based on this framework that we proposed. Before I started talking about the mechanisms of suspension feeding, it's important to say what is suspension feeding. So an animal that is a suspension feeder captures particles suspended in the water. And they can make a filtration. So filtration is not a synonymous of suspension feeding. Filtration is a type of suspension feeding, right? We can say that can be a filtration is a filter is using, like mucal nets in amphibians, bristle in copepods and rakes. So suspended particles occur in small quantities, and they are too small to be captured individually. So they had to be concentrated. In this context, the animals that are suspension feeding develop some mechanisms feeding. And these mechanisms are categorized in three phases. The first one is the encounter, that is based on aerosol theory. The second is the capture, and the third is the handling. So we can see in this scheme. Okay. So you can see here we have polychaete and his tentacles. In black here we have the particle, right? So when the encounter occurs, we have the particle encounter the tentacle, and this particle can be lost or can be occurs a rotation. If a rotation occurs, we have the second phase that is capture, right? And this particle has to be handled and transported in direction to the mouth. This can be occur by cilia or by the movement of the appendage in direction to the mouth. Here we have our framework, classification framework that we proposed. So we have here phase 1, phase 2, and phase 3. In phase 1, we have the mechanisms based on the aerosol theory. I will talk about each mechanism because we don't have time for this, but what it is important here is for each mechanism, we have something that influences these mechanisms. In phase 1, what is important is the particle. So the size of the particle, the mass, the velocity, the charge of the particle, or the viscosity of the fluid that the particle is inserted. But for phase 2, what is important is the organism and his capture structure. The morphology of the structure, the behavior of the organisms, the superficie of the structure. And here we have the phase 3, right? That is the motion of the particle kept to appendage or promoted by ciliar beating. In the literature, the mechanisms of the phase 1 and phase 2 is a little bit confused. Sometimes we can see mechanisms of the phase 1 cause mechanisms of capture, so it's a little confused. Because of that, we did this scheme, this classification framework. And here we can see that the cilia can act in the 3 phases. And what other thing that is very important, that is we can have 2 or more mechanisms acting in the same phase. Because if you have the particles with different size, for example, or different mass, we can have 2 or more mechanisms occur at the same time. And for phase 2, we can have 2 or more mechanisms occur in the same organisms. And we can have, if for the same organism during the development of these organisms, how they change his morphology or his behavior, the mechanism can change too along the development. And here we have the scheme that we propose for jellyfish based on this schematic here classification. So we have here 2 types of jellyfish. So here we have the tentaculate and gerpapel medusa like hydrozoans. And here we have a medusa with oral arms and roller propulsion like rhizostomes and semiostomes. For first phase, sorry, I forget it. This type of medusa can be passive ambush and have a feeding current generated by cilia on tentacle. And here we have feeding currents generated by pump and bell and by cilia, right? Here in the first phase, the mechanisms of encounter is the same that was available in the literature. So we have direct interceptation, motile particle deposition, and inertial pactation for both. And the collector element can be tentacle for this type of medusa. And here we can have the tentacle and oral arms like in semiostome, or just only oral arms like in rhizostome. For phase 2, we can see that we have only nematocysts can be mucous in this type of medusa too, but the majority is talking about nematocysts. In the phase 3, we have the motion of the tentacle and cilia beating. In this case, the same, but we can have the motion of the digitata to transport the particles in direction to the mouth. So this is what we found in the literature. But we came back to my asking of the beginning of my presentation, and I talked about the indications that cilia acting to capture mechanisms and to promote flow, right? The indication is quantifications of the energy value of dietary source based on the prey capture by nematocysts do not fully account for the energy expenditure of this jellyfish. So probably there are another resource of carbon to produce energy that can be very, very small particles like bacteria or particulate organic matter. And we saw the presence of cilia and digitata that promote flow and can influence the biomechanics of fluids and can collect particles too. So it is this. Thank you for my presentation.